Is there room for another 3D printer on the market today? Stick around and find out. Hi, and welcome back. I'm Tim, and this is DWIT 3D Canada. About 7 weeks ago, I was approached by a company called Sceoan. I'm not quite sure how to pronounce the company name, but anyways, I was approached by this company, asked if I would be interested in receiving their prototype Windstorm S1 3D printer to unbox, to play with, to test, run test prints, critique, provide feedback for what I like about it, what I don't like about it, what could be improved on it. And I'm about to show you the results I've had with this printer. The big question on the mind, obviously, is can another company break into the market of today's competitive industry in 3D printing with another unique design 3D printer? The one thing you will notice about this printer through the video is that it is completely wireless. Of course, obviously, except for the power cable, which you have to have a power plugged into it, but otherwise you don't see any wires on this printer. They're hidden. Anyways, come along, watch my video, leave comments, your thoughts, your comments, what you think could be improved on this printer, what you like or don't like about it. But anyways, let's have a look at this printer. Okay, let's cut the box open. This came very well packaged. There was no damage to the box at all, considering it did ship overseas from China. So I was quite impressed with that. So we'll remove this top padding, and you'll notice first thing we see in there is a small spool of filament, 250 gram spool of sample filament, standard. It's in white. I don't like the white samples, but hey, it is what it is, right? So anyways, we have the spool of filament, and then we have our power cord, obviously. Now, this was a little bit tough to get out of the box, so I had to go on the floor and kind of just muscle my way and lift it out. But it was very well padded. There was no damage visibly that I could see. So as we unpack the printer, it is strapped together with these straps to keep it all in one piece, and as I say, very, very well packaged. So we can dwell into the packaging now. This box contains a few different items. So the first thing we see is, of course, our standard pair of snippers. We all have hundreds and hundreds of pairs of those things if we do 3D printer reviews. Then we have a set of hex keys. These are just flat end hex keys, they're not ball end, nothing special, just a standard set of hex keys. And then we go ahead and we open up, we have a USB cable. Again, we got dozens of those lying around. And then we have a USB stick, which contains some sample files and some software, etc., etc. So, and a few print sample files on it. So there we go. And the next thing we're going to pull out of the box here is the spool holder. And this is the core, or the spool holder core, which goes through the spool. A couple screws, 2 bolts, which is all we need to put this machine together. And then we have the spool holder itself, which just was going to stick into the top of the printer, as you'll see a little bit later. And this will hold a standard and a little bit of wider size spool. So from what I've tried so far, it holds all sizes of spools that I have. So, okay. Machine comes in 2 parts. We have the top, the gantry portion, which we're going to put aside here for now. And then we have the base, very solidly built base. It's got some weight to it. It's not as light as it may look. And it is constructed of all cast aluminum. So other than that front panel you see there, the whole thing is aluminum. Okay, as we look at the front of the printer, first thing you'll notice is we have a USB port, a micro SD port, and a USB-C port, as well as a little switch there for resetting the display. And on the back of the printer, we have our standard USB-A port and a place to plug the printer in, and the on-off power switch. Pretty basic stuff here. Oh, and 2 holes there for attaching the gantry. Anyways, you'll notice the unique bed design. It's kind of a sunken bed design, which is something new. It also comes with a flexible PEI build plate with alignment pins for putting the plate back in place after you take your print off of the bed. So, Yeah, let's have a look at the gantry now. Now this is, again, as I said off the top of the video, it's a wireless printer for the most part. You don't see any wires. And you'll see here in a second why you don't see wires coming off the gantry. If you look, you'll see that there is a connecting pin here which plugs into a receptacle in the base, and that's how all the power and everything gets up to the hot end and up to the motors. So we just plop that on like that, and then we turn it around and we install those 2 bolts. And that is basically all there is to the assembly of this printer. Once those 2 bolts are in place and tight, the printer is ready to go. We just pop on the spool holder on top like that. It's a swiveling spool holder. And we pop on a spool of filament and we are good to go. And so the assembly of this printer is extremely quick. There's nothing to it and you're done. That's it. So let's have a look at the display. This is quite a unique, different display than I've seen myself before. Full color display, very responsive touchscreen on this. So we can hit the print button. We have the option of where we want to print from, TFT, our micro SD, or our USB card. And then we go in and we're going to show some of the different options here. So it has a thing called terminal. I don't know what this is for myself. I think this is for directly programming the EEPROM, but now we can go through here. We can disable steppers, initialize the cards, restore from EEPROM, etc., etc. If we go into the settings here, we have different ways of connecting the printer. Again, some of these things are active, some of these things aren't. As I say, remember, this is a prototype printer. So as I go through all these display items and different menu options, some will work and some won't. But being a prototype printer, we pretty much expect that. So yeah, so I've just been playing with a few things here. Here's one of the cases where it may be a little bit buggy because it is a prototype. So all we do here is, because the screen's not responding, we just hit that little reset button and that'll reset the display and then we can move on. So as we get back to the home screen here, we'll go look through a few different things again. Let's hit the, oh, we've already been through this. So we have an emergency stop button, just kills the printer basically. We have a shutdown button if we want to shut everything down, the heaters, the fans, etc. And then if we go back over here, here's another area where I found it to be a little bit buggy. So we can touch the screen to calibrate, but there's no way to get out of this. So again, keeping in mind this is a prototype printer, there are going to be issues. This is one of the other issues. It keeps telling me that the adjustments failed, so we just reset the screen again and move on. And our next thing we're going to look at on here is we'll go back into the menu, back into the settings, and let's go to the machine settings here. So again, we can adjust our steps per millimeter on the X, Y, Z and extruder. And yeah, I mean, the basic things you're going to expect to see when you delve deep down into these menus. And of course, as they do any updates or provide me with any firmware updates, I will go dwell deeper into these things and we will explore what they all do. Now here is possibly a future feature, some LED light settings, but I have not seen any LED lights on the actual printer itself. So I assume this is just a future function of the printer. So again, we'll just keep going through the menus here so you can have a look at what's going on. Some features, as I said, are not working at this moment in time, but we know why that is. So that's good. It looks like we can just do reset our EEPROM as needed. And we'll just go right in here. We can do PID tuning directly on screen, which is really a nice feature, which you see in most printers these days anyway. So we can PID tune the hotbed and we can PID tune the nozzle. No, I'm not going to cut those little glitches out because I'm only human. Excuse me. And we can adjust some offset settings here. There's a lot of interesting features in here that at this moment in time, I'm not 100% sure how they're used. This printer didn't come with any manual. As I say, it's a prototype. There's no manual with it at the time, but I'm sure that's something that will be provided in the future. So we'll just keep going through these features here, and if you have any questions about them or want to see anything more specific regarding some of these features, just go ahead and ask me in the comments, and I will do my best to answer the question, or test out any of these features that you might want to know. So yeah, so we have a few different defaults that we can set here as far as auto leveling, etc. It does come with an inductive probe built into it, which we'll see later when we look at the hot end, and they do have settings in here also for a BL Touch. So I think there's different options for different leveling tools on this printer, so it's kind of interesting. Maybe they will just stick with one or the other. So as we keep going through here, what are we going to look at next here? Let's see. Okay, yeah, so we are running Marlin on this. This is updated as of November 14th, 2023, and it is, I believe, should be the latest version of Marlin that's on this one right now. And then our standard homing, moving, extruding. Again, we have semi-automatic filament loading, semi-automatic filament with unloading. I say semi-automatic because you have to physically put the filament in the hot end to load it. So this is just all the move buttons. And as you can see, for the most part, as I push these buttons, it's a very, very responsive touchscreen, which I was quite happy to see. I have seen touchscreens on printers that are not quite as responsive as this one, so I was quite happy to see this. So here we go. This is where we can load and unload our extruder. We can set the speed we want to load and unload it. We can set the distance we want to unload and load, how much filament to unload. The one thing I did notice on this is that it does need to be set so you can load a little bit more, so you can purge a little bit more filament as you load it. So again, auto bed leveling, mesh edit, mesh valid. Now we have an interesting thing called Z-Fit. I don't know what this does, so I think this is more so to do with if your bed is not quite level. But again, we'll learn those things as we move forward with this printer. So we can set our preheat temperatures for different filaments here. Of course, I'd probably never run ABS or nylon on this because it's not an enclosed printer, but we have the option for presetting different filaments. I have not found where to go to program those yet, but we'll look at that down the road as well. So, and then just some more standard buttons that you'd expect to see on any of these displays and any of these printers these days. So okay, so we'll just jump ahead here a little bit. It's got some settings here if you happen to have a BL Touch on here, or if it comes with a BL Touch, where you can set your probe offsets. And it looks like you can turn your BL on or your BL off. I'm not quite sure how that works, but we'll figure it out. It does have auto bed leveling, so you can program it to level your bed and it will save it to the EEPROM for you. So that's pretty much it for the display. Now let's go ahead and move on to some printing. Let's go. So let's go ahead and start a print here. This first print was a sample print that came on the USB stick, and it is called, I believe, filament support or something like that. Anyways, I have no idea what it is, whether it's even something that works on this printer or it's just put on there as a sample print. That's fine. But so anytime you see the clock running at the bottom of the screen, which I did on a couple times here, that's just to show you that that's real-time speed. I haven't sped it up, and I am going to be speeding the video up here just so I don't bore you through the whole print process of this piece. We're going to just make this real quick, but I did slow it down to real time a couple times just so you can see the speed of this printer. It is being marketed, I assume, as a fast printer because it is a fast printer indeed. So obviously this is sped up, and we're going to get to a point here when we get down to the second and third layers where right here it is real time. This is the real speed, and it's a pretty fast printer compared to some of the other bed slingers that I have. But I think other companies out there are setting the standards for speed in bed slinger printers, and these guys are obviously keeping up with that. So, well, if you hear that noise in the background, there's a vacuum going above my head here in the main living room. So forgive me if you hear the odd noise up through this video. So here we go, we're going to speed this up just to get this done. And I was quite impressed with the quality of this particular print, considering the speed it was going. Here we go, I just jumped ahead to the end of the print here. Again, I have no idea what this piece is for. It was just a sample print on the USB stick that came with the printer. So we'll finish it up here and we'll pop it off of the bed. And it's a good looking print. Oh, just a side note, initially the filament wouldn't stick to the bed. I did have to use some 3D lac to help with the bed adhesion. So, but nice looking first layer, or bottom layer. And top layers look pretty good. Everything about this print looks really, really good. So, next thing we did was go ahead and print the benchy that was on the USB stick as well. Now this print isn't going to turn out as nice as the first print did, and this is where one of the first issues with this printer is going to show itself. Cooling. You'll notice there's no cooling ducts that are pointing down towards a nozzle. It's because the way they've set up the cooling on this printer is different than I've ever seen actually. And personally, I do not think it's a really effective way of cooling your prints, especially when you're boasting that this printer is a fast, high-speed printer. It's great, but you need better cooling to achieve these speeds effectively. So as we look at this benchy, when it comes off the build plate here, you're going to see the issues with cooling. I don't have to tell you guys that this is not the best looking benchy out there, considering it was about a 17-minute benchy. The cooling on it is terrible, and that's because of the way the cooling is designed, which you will see when we pop open the hot end. I will show you how this cooling is happening. So that's it for the printing test for now. We just printed a few different pieces to try. Until we get some cooling issues fixed, I don't think we can really print many other size models. So for now, let's go ahead and have a look on the inside of this printer. And here we go. So we pop the flexible bed off, and there are, excuse me, there are 4 screws that we have to remove in order to remove the bed itself. So we will zip through these. I'm not that fast. And once the bed comes off, you'll notice no wires. It's, again, wireless printer. So there's 4 pins there that plug into a slot which powers the bed, which is really nice to see. You don't have those wires hanging off the back of the bed that you have to worry about whether they're getting kinked or not. So, and then there's another cover here we're going to remove, and again it's, I believe, 6 screws this time to remove this top cover to expose what is underneath this plate. And that'll just slide off the back, and it's got some padding there, I believe, just to reduce vibration on that plate because it is a thin aluminum plate. And then we'll turn this around and have a look at what's going on inside here. So you can see the wires that are just up there, which are connecting the display. Now, there is a way to pull the whole electronics device out, but you have to disconnect a lot of wires. I haven't done that right now, but I'm going to do that perhaps in a future video. So here's a good look where the bed runs along the 2 vertical linear rails that are there, and you also get a good look here at the connector where the bed plugs in. So that's pretty much it for the inside here. Let's go ahead and have a look at the hot end now. So removing this hot end cover is pretty simple. It's 3 screws, and then the plastic cover just slides off. And you'll notice inside here we have an inductive probe, all your wire connectors, which is standard. You have an inductive probe. There is our hot end cooling fan. And if we remove the sock, we can see we have what's becoming standard these days with thermostat and the heater built right into the hot end. And this uses a standard M3 nozzle. So if we look at the other side of the hot end now, we can have another look here where we have the wires going into the daughter board or a breakout board there. You can see the heat sink on the hot end. Now if you look here, this is where you'll see the cooling. If you see that fan in the back, all that is for part cooling, is that fan blowing down onto the nozzle in no general direction, which is, in my opinion, a very poor way to cool a part, especially when you're dealing with a high-speed printer. So this all pops off pretty simple if you want to take that off to service your hot end. It was just 2 screws there to remove the heat sink. Putting it on is just as simple again as pushing that up and replacing those 2 screws. So, but again, you can have a look at the back where you can see that fan, and that is the cooling right there. That's the cooling fan, and that's all there is to cooling. There's no directional aiming of the cooling or anything, which in my opinion is a very, very poor design. Okay, that's it for the hot end for now. I just wanted to pop open the top here and have a look at the how the 2 Z rods. So we have linear rods and we have threaded rods for the 2 Z's, and we have a single motor running these rods. I wanted to pop this open to basically show you the belt path here, which is kind of interesting too. So they're kept in sync obviously by this unique belt path. I say unique because I've never seen one like it before. And they do have a really cool way here of tensioning. So you can tension your belts. There's a couple screws and a plastic piece down there where that one pulley is attached. And you just loosen those 2 screws and you can pull that pulley to tension your Z belt. So that's pretty cool how that works. And that keeps your 2 Z rods in direct synchronization. So we did one more quick test print of this Flexi Factory Dolphin using Polymaker PLA filament, just to show you the issues that this current cooling system has. So you can kind of see there on the fin, the bottom layer is no problem. Everything printed fine for the most part, although there are major cooling issues that need to be fixed. So yeah, we will discuss that with the manufacturer as we move on. So, in conclusion, we're going to do a little bit of a conclusion here as well as show you what's going on right now. I personally think this printer has some potential. There are a few things that I definitely think need improving and fixing, mainly the cooling. So far the cooling. The way this thing is cooling is very inefficient and just doesn't work for high speeds and doesn't work for some models. Like on this little test model, the cooling worked perfectly because there was nothing really, you can't go wrong on a piece like this. But on models like the Benchies, which we ran, and on this Dolphin, which we ran, you can definitely see how ineffective the cooling they have on here is. And especially when you're touting a high-speed bed slinger, you need really, really good cooling. So there are a few items on the menu that need translation to be translated better. It's just lost in translation. There's a few things on the menu that don't work, a few things that are buggy that cause the menu to freeze up. But again, the manufacturer has stressed to me to stress to you that this is a prototype printer, and again, that's what prototypes are for, to find all these bugs. But otherwise, it's solidly built. It's heavy. It's two screws to put it together. Completely wireless. We have linear rails throughout that are running. All of our axes are all linear rails. I cannot easily access the main board and the power supply, although it is automatic switching power supply, so it does detect the voltage from wherever it is you're plugging it in. But I'd still like to see a little easier access to underneath in order if I need to service the board, if I want to change out some fans, if I want to switch out a power supply, etc. I'm pretty sure this is being aimed as a non-tinkering type printer. So, which is why it's not as easy as it could be to access underneath and access all the electronics. But that's another one of the appeals here, is that it's so clean. It's almost like an appliance you would see in any room in the house. It's so well designed. It's mostly aluminum. There are a few plastic parts on it, but for the most part, it is aluminum all around. It's heavy. It's solid. It's very solid while it's running. I'll switch over here and show you. Right now I am running a print just to utilize a larger portion of the bed. We're getting an excellent first layer on these prints here. Okay, I'm gonna get my sound meter out here and show you guys how loud it is once we get through this layer. I'll just cut the video as needed, and we'll show you how loud it is when we get to the second layers, when it starts to really speed up. Yeah, I'm going to keep working with the company on this, and we'll see what they come up with. It's a brand new company, and again, this printer is called the Windstorm S1. I cannot easily pronounce the company name. The company name is spelled S-C-E-O-A-N. Sceoan, I don't know, but that's okay. That's not important. What's important is I think that they have something potentially good here. The fans are a little loud, which you will hear once this gets up beyond the first layer. The fans are a little bit loud, and that's just a matter of maybe switching out to quieter fans. But otherwise, I'm going to continue working with this printer. I'm going to continue to do test prints. I'm going to break it down further. I'm going to take it apart further. I want to open up, I want to see the electronics, I want to see the main board, I want to see how things are wired underneath, whether ferrules are used, etc., etc. But I want to really give this thing a good, thorough look through and continuously report back to the company and let them know what they can do to improve this. And depending on the price point that this comes in as well, that's a key factor right there based on the competition that's out there in this field. And we all know the big one that's out there that just released a very good bed slinger with multicolor and high speed, etc. I won't mention the company, but I think you all know it. But these guys have some competition out there, so they've got to come in at an attractive price point for anybody to even consider looking at one of these. Again, the pluses are completely wireless. It looks great. It's just overall, it's a good feeling printer. It's very well built. And literally, you can say you can be up and running with this printer within, I'd say, 5 minutes. Just by 2 screws, gantry on, 2 screws, you're ready to go. So that's my thoughts on this. If you guys have any questions, you want to see anything else on this printer, you have any concerns, anything you think that I should be reporting back to them just based on what you've seen in my video, leave it in the comments below for me. That would be really, really helpful. Because it's always nice to have competition out there. It's healthy, and it keeps all the other companies honest when they're going to release printers. So I'm going to pop in the sound once this gets to the next layer, and I'll just be editing that. You'll see that in a moment now, thanks to the magic of video editing. So we'll be right back with that. Okay, so here you go. We've got beyond the first layer on this print, and we are at the high printing speed now. So you can basically see how fast this printer is going in real time. And we'll bring the decibel meter in here, and we can keep an eye on how loud this printer is. So we are, looks like right now we're at 67, 64 decibels. And it peaked at 70 at one point. I'm not sure if you can hear. Let me bring the mic a little closer as well. See if you can actually hear how loud this is. It's not so bad. With me talking, it's peaking around 70 decibels. And then here, we're going to see the next layer go on here. I'll just let you see this go for a little bit here. We're printing in Polymaker PLA right now, so it obviously added second skirts there, but look, this thing is very fast. We are running at 220 degrees, 65 degree bed. And there we go, and let's get the meter in here again. Pretty fast. And there we have it. The Windstorm S1 prototype printer. Leave your comments below again, and thank you for watching, and we will be continuing to work on this, so watch for more follow-up videos that get more into the insides of the printer. And as improvements are made from the company and they send me, whether it's another printer or whether it's upgrades to the firmware, we will keep you updated on this channel. So subscribe to my channel if you want to keep following this progress on this printer. And we also do all sorts of other things on this channel. Thank you for watching. I appreciate it. Take care for now. and stick around for the outtakes. Yeah, bye for now. Today we're going to take a look at the all-new... Today we're going to take a look at the all... Okay, got take 3. Hi, welcome to DWIT 3D Canada. My name is Tim. Today we're going to take a look at the all-new Windstorm S1 3D printer.